Okay, guys, example number 3. It says, tell whether the relation is a function. Let's look at the first one. Now, guys, well, I'll tell you what we should do first. I'm going to do a mapping diagram, okay? So I'll do my input right here, and then I'll put my output over here, okay? And let's see. I've got 2, 4, 5, 5, and 7. And then in the outputs, I've got 32, 59, 65, 69, 96. Okay? And I'm going to draw my arrows. Okay. That's it, smartboard people. Thank you. All right. Now, let me stop with that one. I just did a mapping diagram, right? Easy enough, right, Fritz? Have you done that on yours yet? Not yet, but you were planning to, I know. Good. It's easy enough. Is it a function, Fritz?
No, it is not.
How do you know it's not?
Because there are two different, the two same numbers, the two fives, have two different outcomes, 65.
That input, the number 5, has two different outputs. All right? So it is not a function. One question, and I know it's not exactly right, but one question, we can't get two separate answers. We can't get a yes and a no. It has to give us one or the other, right? Now, let me ask you this. Can two different inputs give me the same output? Is that a function? That is a function. Are you in the 7th grade, Armand? Yes. Do you go to Cathedral Tut?
Yes.
Two different questions, same output, same answer. That's okay. That is a function. Okay? But if I had the same question and get two different outputs, that's not a function. So let's look at this next one. In fact, I'm not going to do anything for this next one. Before we get to it, does anybody see a shortcut? When you're looking at these things, you see a shortcut? I did this mapping diagram over there to the right for the first one. I'll put A up here so we'll know that's the one I'm talking about. But did I need to do that? There may be a shortcut. Trigo, what shortcut do you see?
No numbers are the same.
When you say no numbers are the same, what do you mean by that?
Well, no x values.
No x values are the same. All right? If I have these 5 points listed, is it 5? Yeah, 1, 2, 3, 4, 5. Got those 5 points listed, right? Not a single one of them has the same x. They all have different x's. So there's no way that it's not a function given those points. It has to have the same x for it to not be a function, right? When we're just looking at a list of points. That's a shortcut, right? So I didn't really need to draw this. I knew it wasn't a function because I could see that 5 right there gave us two different outputs. But over here, I don't even have the same x listed anywhere. So there's no way that I'm going to get a different y for the same x. Cole.
On a test, would we have to put the mapping thing?
Cole asked if we have to do this on a test. You know what? I'm going to say no, Cole, that you don't. I mean, you can use that shortcut if you just look at it. But I may say, why is it not a function? You know, I may say, tell if this is a function, explain. Right? And so if you did that for B, you would say, yeah, it is a function because no x value gives more than one y value. All right? And that would be it. Yeah, Justin.
So if there are two of the same x values, but it's also two of the same y values,
Then they're just a duplicate and it is a function. So Justin's point was, if I've got two x values, but they also have the same y values, then that's just a duplicate and it is a function. But we're not going to see it do that, usually, in a problem that the teachers give us. Teachers give us problems for certain things, you know. Well, I don't know what that means. But I tell you what I'm going to do. Oh, hey, there we go. All right, fair enough. Nico, quickly, because I'm running out of time. What you got?
Did you have two, let's say that they write 5, 5, and then they're both equal 65, would that still be?
That's just what Justin said. It's a duplicate.
Okay.
Okay. All right, good job, guys. Let's look at the next example.